Alrighty, in this video we're going to go ahead and start working on our serializer. So our serializer is going to be a very important fundamental class to the entire system because it's going to allow us to invoke methods over the wire. Because, well, one of the most important things about invoking a particular method is passing data from the client to the server. And of course we'll need to have some sort of serializer in place to do that. Now there are a variety of ways to serialize data. We could use anything from JSON to XML to Bison. We could use protocol buffers. We could use, I can't remember the name of it, but there's another binary format that's pretty popular these days. But they all suffer from one problem or another. And it really boils down to the fact that the majority of these serializers are really designed for data storage and not so much data transmission. What do I mean by that? Well, most of these formats, especially XML, Bison, JSON, are self-describing formats, meaning you type in some data and you annotate what that data is. But that doesn't necessarily translate well to a protocol that you would want to use in a real-time scenario. And the reason for that is you would have to repeatedly say, okay, this bit of data is for this property, and that bit of data is for that property. For example, I can just go ahead and pull something up real fast here. Pull you up. So for example, if we were working with JSON, and we wanted to write a method or write a method that accepted invoked some sort of ability, and we need to pass something like the target of what we want the ability to hit. So we might say something like the ability ID is 4 and the target ID is 32 and so on and so on. We might specify a bunch of this information. Or what about movement? Movement would be even worse. We would have something like position, and we might have an array here of, 0, 1, 2, 4, or whatever, and then rotation, and we might pass in a quaternion here, so we might have a bunch of other values just for values for that. And the point is that you notice that this data format, so JSON and XML in particular, they describe the data that they're passing inside of the data itself. And I don't find that particularly optimal for real-time communication between a server and a client unless there's a restriction that you have to be text-based, like for example if you're working on a website or web application. But in this case, we can take advantage of binary protocols. And really the only way that we can take advantage of a binary protocol or a binary protocol that doesn't describe itself, is if we have some sort of scheme or schema of the data we want to send available on both the client and the server. And what do I mean by that? Well, I mean, we need to be able to say, okay, the first 4 bytes go to this thing, and the next 5 bytes go to that thing, and the next 6 bytes go to that thing. We need that information somewhere. But in this case, that information has to be available on both the client and the server so that the data itself can be as compact as possible. For example, this example right here, where we have the ability ID, ID and target ID, wouldn't it be much simpler to have a byte stream that we would just have 4 or 2 1-byte numbers and let's say 2 4-byte numbers? So we would have a component ID of 3, a method ID of 2, an ability ID of 4, and a target ID of 32. Wouldn't it be better if we just sent that across the wire in a binary format? Because this would only take it up 1, 2 bytes for our component ID and our method ID. Then it would take in, or it would require, we have 4 bytes for our ability ID and 4 bytes for our target ID. So that's 8, 10 bytes. We can further compact it by maybe having our ability ID just be a byte as well. Although our target ID would probably not be able to be a byte because we don't want to limit there to only be 255 things you can shoot at in the game. So anyway, the point is this will significantly reduce bytes because you're talking about 10 bytes. If we're doing JSON, for example, I mean, let's count how many characters we have here. I can tell you right now it's more than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, that only gives us the property name of the ability ID. Bison is a little bit better. If you're not familiar with that, that's binary JSON. It's a little bit better, but it's still a self-describing data format. And again, that's not something we want to do. I will point out one actually big caveat to all of this. JSON is great, so is XML for self-describing data, which is almost all but required if you're wanting to do any form of persistence. See, I consider the concept of persisting data to a disk or to a database to be fundamentally different than transmitting data in real time. So what I mean is that our serializer will not be an appropriate choice for persisting data. But that's okay, because none of this data really needs to be persisted. It's just used to transfer data from one system to another system. If we want to persist data, we could use any other format that we would want to on the server side. So it's not really going to be that big of a deal here. And it'll afford us quite a bit of bandwidth savings by creating a format that is not self-describing. So what we're going to do is we're going to put together a very simple binary formatter, or a very simple binary serializer that is non-self-describing. And you might be asking, well, you said earlier that both the client and the server are going to need a schema to know what bytes go to which things. And my answer to that would be we already have one. We already have one in the form of the component map. Because with the component map, we can know if the client is trying to invoke, method A on component C, we can just look that up in the component map, we get his method info, and then we have a list of types that method requires for parameters, and we have our schema. So that's how we're going to handle the serialization and deserialization. That being said, this particular serializer is actually going to be a very simple form of a serializer I'm intending to write later. I do want to take the concept of dynamic code compilation and combine it with our data format to create a very fast and very lean serializer that has a lot more features. But for now, we're just going to work with a very simple serializer that I'm probably going to call Simple Serializer, that will use reflection fairly heavily to do its magic, but it's going to be hidden behind an interface so that in the future we'll be able to replace it with our own custom serializer. Now there's a couple interesting features I want to implement with the serializer. I want it to support basic types. First of all, I want to support primitive types, so we're going to be supporting strings and floats and bytes and blah blah blah. We're going to be introducing some other types that I want this serializer to support natively, such as our actor IDs, our player IDs, and so on. But I also want to support things like arrays, enumerations, and then in addition, I also want to be able to support polymorphic serialization. And what I mean by that is I want to be able to have an RPC method that takes in an interface, and I want to be able to instantiate a class that implements that interface and send it over the wire. That's going to require some other special considerations as well. I want to support complex types in the form of a custom serialization interface. For example, if I want to have a complex type that I want to shoot over the wire, I want to have the option of having that type implement a special interface that will put it in control of its own serialization. And then the final thing that I want to do is I want to be able to have types serialized as JSON, or particular Bison. And you might be saying, well, you just said that Bison is going to be terribly inefficient for all this, and yes, it's true, but there are going to be some instances that do not happen frequently whatsoever that will benefit from allowing us to use JSON.NET in particular. And the reason for that is JSON.NET, that serializer is very powerful and very capable of serializing complex object graphs, and being able to shoot those across the wire in very, very specific circumstances is going to make our lives easier. That being said, it's not something we're going to do all the time or even very frequently at all, but I want the opportunity to be able to actually instantiate a complex object graph over the wire, and we'll just use Bison for that. Okay, so let's go ahead and jump right in. We'll go ahead and start by writing the iSerializer interface. So I'm going to create a new interface in the infrastructure namespace of buzzmmo.base, and I'm going to call it iSerializer. So iSerializer, because I can spell, I swear. The iSerializer interface is going to have 4 methods on it. We're going to have void write arguments. That's going to accept a binary writer. It's going to expect, then it's also going to accept, well, there's a variety of things we could do here. We could have it accept a method info straight up, or we could have it accept a array of types, which I think that's what I'm going to go with. In fact, we could just get away with doing an IEnumerable of types. And then, of course, we're going to need an object arguments, which object arguments could also be an IEnumerable of arguments as well, or IEnumerable of object as well. So we have write arguments that takes in a binary writer, the types, and then the arguments. You'll notice that we are not going to be, for our write arguments, you'll notice that we're accepting the types in a different format. And by format, I don't know why I said that. We're accepting types in the form of an IEnumerable of type rather than grabbing the type off of the object arguments. You might be wondering why I'm doing that, because we could certainly loop through all the arguments and invoke .getType on them to establish what type they are to perform the serialization. The answer to that question is that our object arguments can be null, for example, or maybe they are a child class of the type I actually want to serialize, and so on. So I really don't want to deal with that. I just want it to be, yeah, stuff and things. Anyway, so now we have our write arguments. We're going to need a corresponding read arguments. So I'm going to say object array read arguments, and it's going to take in a binary reader in an IEnumerable of types. Next up, we need to do a write object, which will take in a binary writer type object value, and then we'll have an object read object binary reader type. And that's really just going to be the interface for how we're going to handle serialization for the RPC framework. So now that we've done that, let's go jump into our infrastructure namespace and create a new class. And I'm just going to create a new class, and I'm going to call it Simple Serializer. Or Simpler Serializer. I meant Simple Serializer. There we go. And he will implement iSerializer, and of course we will bring in all 4 of his methods. So we have write arguments, write object, and read object, and these are the 4 methods that we're going to implement. Now fortunately, write arguments and read arguments can be written in terms of write object and read object. We just have to go through a loop. So that's going to be fairly straightforward to implement. So what I'm going to do here is on write arguments, I need to loop through types and arguments at the same time. A simple way to do that would be I'm going to open up a IEnumerable of type iterator. Actually, I can just say var type iterator or type enumerator equals types.getEnumerator. Then I can say, actually, let's make this a little bit more consistent with the .NET framework. So using type enumerator equals types get enumerator. Using var argument enumerator equals types or arguments dot get enumerator. And then I'm going to say while type enumerator dot move next. Then I'm going to say write object, passing in the writer, the type enumerator dot current, and the argument enumerator dot current. And what that'll do is that'll go ahead, loop through both of these IEnumerables simultaneously, and write all that stuff out. Now you'll notice that this will have a potential bug if the amount of items in types is different than the amount of items in arguments, but I'm not really too concerned about that. Also, I forgot to move the argument enumerator forward, so I'm going to say and argument enumerator dot move next. All right, so now we have read arguments. So read arguments first needs to get however many arguments, it needs to pre-initialize an array of objects for however many arguments are going to be. So I'm going to say var return value equals new object of types dot count. I'm going to import system link for that. Yeah, I'll do that. Later, I'll do a performance different. I am actually curious now what the performance implication here would be for me using an IEnumerable of type instead of a type array. And I am curious about that. We'll go ahead and keep on writing our code using the IEnumerable of type and IEnumerable of object for now, because fortunately it only infects these two short methods. But then I'll do some performance tests later on that because I'm curious about that actually. Okay, so return value is going to be that. Then I'm going to say var index equals 0. Then I'm going to say for each var type in types. Then I'm going to say return value at index plus plus equals read object reader type. Then I'm going to say return value. And it's going to complain about possible multiple enumeration of IEnumerable. I'm going to go ahead and suppress that with a comment. And there. And I won't worry about re-enabling that error either. Okay, so our write arguments and our read arguments are done. Now we have our write object and our read object. Now, like I said before, there's a variety of different things that can happen here. It could either be a, well, first of all, it could be a nullable type. It could be an array type. It could be an enumeration type. It could be a polymorphic serializer, a custom serializer, or a basic value. So what I'm going to do here is I'm going to first just write code that will handle basic types, and then I'll just go from there and add additional behaviors to my serializer. So the write object method is going to start off simply by invoking write simple, passing in writer, type, and value. The read object is going to simply return read simple, passing in reader and type. Now the write simple method is going to be a private void read simple binary writer type object value. And whoops, I meant write simple, not read simple. Okay, so the write simple, let's go ahead and do some basic type checking and writing. So I'm going to say if type equals type of, what do you think the most likely thing is going to be? Well, I'm a big fan of uints, so we'll do if type is type uint, writer write uint type. Or whoops, uint value. Else if type is type of byte, writer write byte value. Else if type is type of string, writer write string value. Okay, so now that we got a couple common ones out of the way, I also need to support some more. So I'm going to say else if type is type of float, writer write float value. Else if type is type of double, writer write double value. Okay, so now that we've done that, let's just do decimal too. Why not? I also got a new keyboard too, so I'm kind of wanting to test out my writing. You'll notice I've been making a couple typos here. It's kind of weird getting used to it. Okay, so we did uint, byte, string, float, double, decimal. So now let's get our other integer ones out of the way. So I'll say else if type is type of int, writer write int value. Okay, now I'm just going to copy and paste. We want int short, u short, long, u long. So int short long, or sorry, u short, long, u long. Okay, so those are all of our integer types, except for char. We don't have char. So else if type equals type of char, right or right, char value. Okay, so we have our int, our uint, our short, our u short, our long, our u long. We have our byte and our char. We have our string, float, double, and decimal. Those are really going to be the big ones. However, there's a couple other ones I want to support as well. I want to say else if type equals type of GUID, then writer.write GUID value dot 2-byte array. So this will serialize a GUID as an array of bytes. Then I want to do else if type equals type of date time, then write date time value dot ticks. Finally, I want to do an else, throw new argument exception, string format, cannot write that. And that's going to be type.fullname, and then I'm going to pass in value as the argument. Alrighty, so that's our write simple. Our read simple is pretty much going to be the exact same thing. I'm pretty much just going to copy and paste it so I get all the right types there. I'm going to say private object read simple, binary reader type object, or whoops, no, object value. And yeah, the performance of this isn't going to be great. The biggest thing I'm wanting to save on is bandwidth more than performance, but when we go ahead and write our more complex serializer in the future, that will definitely have performance more in mind. Okay, so read simple, I'm just going to really copy the contents of write simple, and I'm going to take off this else right there and just say throw new argument exception all the way at the bottom. And then instead of writer.write, I'm going to say return reader.read uint 32. For byte, ooh, I forgot bool. Reader.read byte. I'm going to add bool in after I get all these done. Also, I can remove all of these else's too. All the else's are now unnecessary because we're immediately returning. And I do like trimming them off. I think it looks a little bit nicer. Okay, so now we have to return reader read string, return reader read single. Remember, a float is actually a single. Double is return reader read double. Decimal is return reader read decimal. Int is reader read int 32. Short is reader read int 16. U short is reader read uint 16. Long is reader read int 64. U long is reader read uint 64. Char is reader read char. GUID is return new GUID, passing in reader.read bytes and then passing in 16, because a byte is going to save as a 16-byte long byte array. And so that's how we're going to pass around GUIDs. And then for our date time is simply going to be return new date time, and then we're passing in reader.read int 64 because ticks is a long. Now let's go ahead and support booleans real fast. So at the end of, actually after char, I'm going to say else if type equals type of bool, write bool value. Okay, so I added this up here. just to make sure that we have support for bools as well as everything else. I mean, that should really take care of all the primitive types that I care to deal with. And then down here, right before GUID, we're going to say if type equals type of bool, return reader read boolean. Alrighty, so this is really the backbone of our entire serialization system because it'll be used for a variety of different things. Most of the parameters we're going to have in this entire code base will be primitives. So most of the time we're going to be hitting this particular set of if statements up here. So anyway, now that we've done that, and we could also do some analysis against our code base later to see what the most common parameter types are, and then put them further at the top of the list. But anyway, that pretty much is all we need to do there. I want to go ahead and throw in a test for GUIDs, date times, and I guess strings. Let's throw in a couple tests for our simple stuff. So in tests base, I'm going to create a new class called simple serializer tests. I'm going to say test fixture public void can read and write. Let's start with string. If string works, I'm going to assume all of my other primitives work. So say varchar equals new simple serializer, and then I'm going to say actually I want to do something to what would be the best way to do this? Because we're going to say var using ms equals new memory stream, and then we'll need our byte array bytes, and then I'll also need a var writer or bw equals new binary writer, passing in ms, and then I want to say sir dot write object, passing in bw, type of string, hello world. I'm going to go ahead and constify this. There we go. And then I want to say var using, or var ms equals new memory stream, passing in bytes, var using br equals new binary writer, or binary reader. I know I have a problem there. I forgot to actually write bytes to anything. But anyway, then I want to say sir dot read object br type of string should be test string. Let's go ahead and fix our bytes. I want to go ahead and say bytes equals ms to array. Let's see if this works. And it works. Pretty straightforward. I do want to take this and abstract this because we're going to be doing this a lot with our serializer test. We're going to be aliasing out or having a reference to a byte array, opening up a memory stream, opening up a binary writer against that memory stream, performing some action, assigning our bytes to our memory stream. Then we're going to be loading up a new memory stream, loading up a binary reader against that one, and then reading some stuff. So we can actually pretty easily turn this into a really nice, straightforward helper method that will allow us to simply pass delegates for testing purposes. So what I'm going to do is I'm going to say private void test serializer. I'm going to pass in an iSerializer serializer. I'm going to pass in an action write. Notice the using system at top, and then an action read. And now I'm just going to do bytes using var ms equals new memory stream using var bw equals new binary writer, and then I'm going to say write, or have to pass an ms to the constructor of the binary writer. I'm going to pass in write Then I'm going to pass in, or say bytes equals ms2array. Then I'm going to say using var ms equals new memory stream passing in bytes. Using var br equals new binary writer, or binary reader, passing in ms. Then I'm simply going to say read. Or I'll actually need to pass in the binary writer and the binary reader to these two delegates. So that'll be actually action of binary writer for write and action of binary reader for read. And we're going to pass in BW there and BR there. So that'll turn this whole test into test serializer, passing in sir, BW, sir.write. Actually, I don't even need to pass in the iSerializer into this, do I? Yep, I don't, because I can just hoist it up. So I'm going to say BW equals sir.write object, passing in BW, type of string, test string. Then I'm going to pass in our read, which will be br, sir read object, br type of string should be test string. And I find that ugly. There we go. So that replaces all of that code. So we have our write object and our read object there. All right, so I want to go ahead and test our GUIDs and our date times. So I'm going to say public void can read and write GUID. Say var GUID equals new GUID. I'm going to go ahead and say tools, create GUID. Let's do in this format. Copy that to my clipboard and go ahead and pass it in. I'm going to say var sir equals new simple serializer. Maybe I'll go ahead and just break it like that. There we go. And I'll do test serializer, passing in a BW, BW write, or sorry, sir.write object, BW, type of GUID, GUID, and then BR, sir.read object, BR, type of GUID, dot should be GUID. All right, let's see if we pass these tests. And we do. Let's go ahead and test date times. Can read and write date times. Another great thing about these tests is that they'll also be very useful for when we write a more complex serializer. So that'll be really cool. At least they'll be really nice end-to-end tests for that. So can read and write date times. Say var date time equals new date time. Let's do 1992 1/21. Say var sir equals new simple serializer. Test serializer is bw sir.write. bw date time. Date time. Read object br type of date time. Should be date time. All right. Pretty straightforward stuff. I mean, the actual serializer as it stands is pretty straightforward and simple. All it does is our write arguments and read arguments, you know, that's whatever. Then we have our write simple and our read simple, which are just really repetitive and boring. But in the next video, I think what we're going to be doing is, well, first of all, we'll start off the video writing some basic tests for our write arguments and read arguments methods. Then we're going to move off into more complicated serialization, because we're also going to need to support nullable types, array types, enumeration types, polymorphic types, and custom types. And so we'll support each one of those as we go on. So we'll see you guys